Okay, so we'll go back to another video. So here we have an algebraic equation we would like to solve. We want to find real solutions x such that the cube root of 6x plus 9 plus the cube root of 7 minus 7x plus the cube root of x minus 8 is equal to 2. So typically when you solve for solutions of some equation, you want to set this whole thing equal to 0 and then find x from there with the products. But here we have a little bit of an obstacle as we have a sum of cube root functions, so that adds a little bit of a challenge rising towards that. But not to fret, since we can actually apply a little bit of some creative techniques by doing a little bit of a substitution, then converting this into some part to the point that we can actually make this easily solvable. So we want to, in some degree, get this so maybe it's in a form of a quadratic equation. So, typically with that's a lot easier solvable compared to when you're dealing with stuff maybe with cube functions or even just anything with higher degrees or radical functions to that sense. So nothing more needs to be said. So a little, it's all algebra from there, straightforward, a hard equation if you want to put it this way, but not so much. But let's actually just jump right in. As mentioned, we want to do the substitution, so I'll let a equals the cube root of 6x plus 9. Then we'll let b equals the cube root of 7 minus 7x. And then for c, it's going to be a little bit different. I'm actually going to subtract the 2, so at least that way we're solving for solutions in the form of some equation equals 0. So I have c is equal to the cube root of x minus 8, and then subtract 2. So what we put this pieces together, so I'll have that so far we have a plus b plus c is equal to 0. So how do we proceed from here? That kind of looks a little challenging from there, right? Well, we can actually apply a little bit of some identity. So I'll multiply both sides with this following expression. So I have a plus b plus c. We'll multiply this to a squared plus b squared plus c squared. Subtract a times c minus b times c minus a times c. And then set that equal to 0, multiply that to both sides. And then if you expand all this out even further, we'll have that a cubed plus b cubed plus c cubed, then subtract 3abc is equal to 0, and then continuing on forward, just add the 3abc to both sides. So now it's just a cubed plus b cubed plus c cubed equals 3abc. That's nice to say that it's a little bit easier such that we plug this back into the substitution over here, which is the next step. These radical signs are going to cancel. And so from here, that's of course, as mentioned, next step. So what we'll have now is so far we have 6x plus 9. The radical is going to cancel out. Add this with 7, subtract 7x, then add this. So let's rewind things a little bit forward and actually expand out specifically for c cubed, since we have a minus 2 outside of the radical. So for some x and y value of the difference and cube that, so we have the expression that that's going to equal to x cubed, subtract 3x squared times y, add this with 3x times y squared, and then subtract y cubed. So if I plug in the values carefully over here, so I'll have the cube root of x minus 8, then subtract 2. So we'll have now this is going to be the cube root of x minus 8, and then we cube this, then we subtract, so it's 3, then multiply with the cube root of x minus 8, and then we multiply this by 2, subtract, well now plus actually, so plus 3, then times the cube root of x minus 8, and then multiply y squared, so in this case this will be times 4. And then last is minus y cubed, so that means we're going to have minus 8. So if we actually expand this out even further, so this will be nice. So I have x minus 8, then subtract 8. And then what I can do is I'll factor out a 3 times 2 times the cube root of x minus 8. So minus 3, then times 2, cube root of x minus 8. Then this with the distribution, and if you put this carefully, so now we'll have multiplied with the cube root of x minus 8, and then subtract 2. And so what's nice is that makes things a little bit easier to plug this back into over here. So let's move to that step. So putting this back into here, so now I'll have x minus 8, then minus 8, minus 3 times, so that's back to that substitution, 2 times the cube root of x minus 8, 3, then multiply with the cube root of x minus 8, and then subtract 2. Okay, And so this can be further down simplified that we now have the following. So what you notice is that some of these terms here are going to cancel. 6x minus 7x is negative x. Add this with x, 0. 9 plus 7, 16, minus 8, 0. So all we're left with now is the left-hand side is going to equal to negative 3. So basically all we're left with is just these terms right here. So negative 3, then times 2 times the cube root of x minus 8, then multiply with cube root of x minus 8, and then subtract 2. And so that just leaves with the right-hand side. So 3 times a times b, so that's not that bad of a substitution to put back in. So that means I'll have 3 times this cube root of 6x plus 9, and multiply with the cube root of 7 minus 7x, and then multiply with the cube root of x minus 8, and then subtract 2. Okay, so that's what we have so far for the left-hand side is equal to the right-hand side. So we can actually put this back together, just put this as a sum equation equals 0. So now I'll have the following. So I'll have this following, add this, so I just add that to both sides, and so set this equal to 0. So now, easily now, what we have to do is find our solutions. So as you can see that I can actually factor out the cube root of x minus 8 divided by 2 and then solve that for 0, so that's not bad. So that means I have the cube root of x minus 8 subtract 2 equals 0, which that can be easily solved to say that we have x is equal to 16. So that's one solution. So that's one solution solved. So now back to the original over here. So I can actually divide the cube root of x minus 8 minus 2 to both sides. And I'll divide a 3 to both sides. We'll leave this negative back the way it is, and then it'll make things a little bit easier. So doing so, we'll have negative 2 times the cube root of x minus 8. Then set this equal to, now we have the cube root of 6x plus 9, then multiply with the cube root of 7 minus 7x over here. Now, nicely done is that the negative 2 is that I can actually put that back inside the radical, so that's a cube that, so it's negative 8, then distribute this. So now we're left with the 64 minus 8x, the cube root of 64 minus 8x. And then I can actually expand this out because it's under the same 1 over 3, that base. So I have now the cube root of negative 21x minus 42x squared, and then add this with 63. Okay, so cube both sides, that gets rid of itself. Then now we'll have 64 minus 8x, and then equals negative 21x minus 42x squared plus 63. Then if we actually just get this in the form of a quadratic function, that's not that difficult. So I'll have 42x squared plus 13x plus 1 equals 0. Then that's nice that that can actually be factored out to have 6x plus 1 multiplied with 7x plus 1. Set that equal to 0. And so therefore our final solutions are just, if you solve for each, 16, negative 1 over 6, and negative 1 divided by 7. And so therefore that indeed concludes our final real solutions that satisfies the following sum of cube root equations, just like that. So not as bad as you think, but there we have it. So yeah, that's pretty cool if you ask me.